In this video, I'm going to give a basic introduction to linked lists. So what is a linked list? A linked list is basically a collection of nodes, specifically a linear collection of nodes. And these nodes are connected through links. Links are basically pointers. They point to other nodes. So in this example, you can see a basic linked list over here. It has a head pointer which points to the beginning of the linked list, and it has a tail pointer which points to the last element in the linked list. And then these arrows over here, they're basically next pointers. So each node is connected to other node, the node after it, using a next pointer. So what does a node hold? Well, a node simply just holds some data and pointers to other nodes. In this example, I'm showing a node for a singly linked list. This node holds some type of data and a next pointer. If you can look at this linked list, you can see that each of the nodes, they have a space to hold data, and then they have a pointer to the next node. Now, basically, if you can look on the last node, its next points to null, and this is how we know we're at the end of the linked list. We know that the last node, there's nothing after it, so once we reach the null, we know that we're at the end of the linked list. Now, what is the difference between an array and a linked list? Well, if you can look here, there's an example of an array. It holds 3 elements, 19, 54, and 12. What if I wanted to add 22 into this array? Well, as we know, arrays are fixed size. And since this array is full, I cannot add to it. So I have to make a new array, copy all the data from the previous array into this array, and only then can I add a 22. So basically, I made a new array, copied the data over, and then added a 22. Now, let's see how we can do this using a linked list. So we have the same 3 elements, 19, 54, and 12. And let's try adding 22 to this linked list. So the first thing we have to do is create a node with the data 22. So we did that. Now what do we do after that? Well, we know that since this is going to be at the end of the linked list, 22's next pointer will essentially point at null. So that is the next step. Now, the only thing that's left is currently we see that 22 is at the end of the link, or 12 is at the end of the linked list. Now we just have to make 22 at the end of the linked list. So 12's next is now going to point at 22 because 22 is the element after 12. Okay, so now we did that, and the only thing that's left is adjusting the tail pointer to point at 22 because now that is the end of the linked list. And we did that, and that is basically how you would add to a linked list. Now there's 3 types of linked lists that are commonly used: singly, doubly, and circular. A singly linked list has each of the nodes has some data and a pointer to the next node. Doubly linked list, on the other hand, has a next pointer and a previous pointer. And as you can see, since head is the beginning of the linked list, there's nothing before head. So essentially, the head node's previous is going to point at null. Similarly, since there's nothing after the tail's next is going to point at null. A circular linked list has the same structure as a non-circular linked list. The only difference is the behavior at the head and tail nodes. In a singly circular linked list, as you can see from the example, the next pointer for the tail node points at the head. Now, if this was a doubly circular linked list, it would have the same structure as a regular doubly linked list. The only difference would be that the previous pointer at the head node would point at the tail, and the next pointer at the tail node would point at the head. In the next couple of videos, we're going to give examples of each of these linked lists. Thank you for watching, and I'll see you in the next videos.